Okay, for today's project, we're going to be doing subroutines, which is a little bit tricky. You have to basically come up, this is one of the first custom ones that you have to come up with your own little project. I try to make a couple of them in most of my classes to have, so you guys have a little more fun, hopefully, and make it your own. So it's going to be a little bit tough, so we'll go through that. The other thing that I wanted to bring up today is you should be done programming your initials, using the can cycles, which basically was creating those holes on 8 locations and facing off both sides. So we are going to start machining those parts. So I'm going to put a schedule together. It'll be basically called, and I'll add it in here, it'll basically be called machining schedule, and I'm just going to use Google Sheets and give everybody in the class access to it. So you'll have to sign up for a time that you want to do it. So you can do it on Tuesday or Thursday from 8 till 10, okay? Either one is fine, but there'll only be like 4 or 5 slots at a time, so everybody gets a chance to get done, and that way you're not standing there waiting on people to do it. So when you do sign up for it, do bring another class to work on or something in case somebody gets behind, but you should be able to get into your time slot pretty good unless we have some major problems. So I'll set that up and you'll see it in there. So make sure you sign up for a time, and then you'll basically be machining that. During the class periods on Thursday, we're going to be working on the subroutines. So let's get started with that. Okay, so I'm going to go through the lesson pretty quickly. The subroutines is a lot like a canned cycle. Remember how it did a drill bit in and out and is one good line of code? Well, a subroutine is the same thing, except it goes down to a program, and whether you're doing programming in C and C class or you're programming in C++ for Microsoft, it really doesn't make much difference. The subroutine is typically at the bottom, below the end of the program is what you'd consider it, and it goes down to the subroutine, writes a little program, and then comes back up to the main program. Okay, so the idea is that basically goes, it's something that's going to be repeated. Is usually why you have a subroutine. Okay, so you're basically going to write a repeating code, and it's not as complicated as it sounds. Where it's used typically is like if you're going to be going the same, say you got to cut out a part and you got to cut it deeper and deeper. It's a pocket and you just got to keep on cutting it deeper. Well, instead of rewriting that code for that pocket 16 times to cut it deeper, you just run down and run a subroutine, and in the real code you would drop your bit a little bit every time. And then in the subroutine you would tell it all the points to go to cut that pocket out, or a big groove or a big slot or something like that. The standard codes that usually work for that subroutines is M98 and M99. Okay, so this is of course just a line number, so that happens when you say the N15 is basically renumber my program. So the M98 calls out the subroutine, so that says okay, this is a subroutine, and you're going to have to run that next. The P500 just says which one it is. That could be P anything. It could be P2. It could be P2000. It doesn't make any difference. It just says, I'm using the subroutine 2000. So it knows if you have a whole bunch of them down below, a whole bunch of subroutines, it knows which one to go to. So the P calls it out in this line, and then it ends up going to the subroutine at the bottom that has an O in it. Which, don't ask me why they didn't just start with a P in the bottom. It would make more sense. But the P says go to the O with a matching number. Okay, so the O will be the first line in the subroutine under the program. After the M2, after the end of program, is where you'll be writing this. Okay, and then we're not going to repeat the subroutine, but you can tell it to repeat the same subroutine like 6 times. Like if you're going to go successfully deeper, 6 times, maybe you're doing a big cutting out a pocket or a pattern repeatedly, deeper and deeper and deeper. You'd say 5 times maybe, or 4 times. So that's what that L is. We're not going to actually use that one. So your code will basically be M98 and the P whatever number you want to use. Okay, and then at the end of the program, the first line you write for your subroutine would be the matching O with a matching number, which is 500 in this case, and then you tell it G91 basically, usually in a subroutine, almost every time. So we've talked about doing incremental or relative positions. Okay, the same thing you'd have in CAD. So far, we've only done absolute positions, right? Where everything's from 0, 0. Well, when you're running a subroutine, since you might be dropping position, the Z will change a lot of times, or the XY will change a lot of times, but you're just still going a certain amount of distance. So what we typically would do is we'd do incremental. So then I can do a pocket in a different spot. So say it's a square. Say I'm just cutting out a square. I'd go so far in the X, so far in the Y, and then so far back in the X, and so far down in the Y. But if I start out at a different position every time, it'd be the same code because I'd be using incremental. Say I'm going 1 inch over, 1 inch up, 1 inch back, and 1 inch down to make a square. As long as I use incremental distances, I can put that square anywhere. I don't have to put it in the same spot because the subroutine, what it does, just like the can cycle, it's going to go to the X, Y, Z position you tell it to. Okay, so right before you call out the subroutine, the M98-500, or whatever your line is, code or number that you're going to use, right before that, you go to the XYZ position you want. Okay, and then you call that out, and now it's going to drop down to your subroutine of M500. Okay, so right below, above the M98-500, you would have your XY position that you want to cut it at. Then you call out M98-500, and it goes down to the O500, and then it runs all those codes. Maybe it goes over 1 and up 1 and down, back 1 and down 1 for like a rectangle. Then a G90 says it's over, and a G99 or M99 sends it back up to the next line, which a lot of times will just be another XYZ coordinate, and then you'll repeat it all over again. You put an M98-500 in there, and it goes back down to the O500, runs the code, says I'm done, goes to M99, goes back up to the next line right below that P500, and that's usually another XYZ, so it goes over there with a G0 on it, goes over there, and it goes to another M98-500 and does it all over again. So you just do the same pocket a bunch or coding a bunch of times. And just remember that the O500 is always after the M02. Okay, what M02 means end of program. Okay, so it has to be at the very bottom. A lot of new students will try to write that code inside the program because it's a little confusing. Well, it's not. It's always after the M02. It's basically a little program by itself after the main program's done. And you can have multiple ones. I think you have to write 2 of them in this. And then you can also have, we'll do it one step at a time. You can also have subroutines within subroutines. They're called nested subroutines. Now, we're not going to get into that. But you can basically have a subroutine that calls out another subroutine and it goes down to it. So that can go on and on and on forever. All right. So have this open when you're trying to write your code, trying to remind you that it's in the main program and it goes from the P500 down to the O500, runs your program, and then goes back up, because these are the codes you're going to need. Okay, just like this, and then your programs are in between. Typically between the P500 and the M2, it's just more P500s and XYZ numbers. Okay. All right, so let's get into the project. Now this one takes a while, so I don't expect, today we're going to focus on getting the drawing done, but I wanted you to understand how it works. Okay, so today the main idea is to get the drawing done, and if you get that done, then you can start, we'll start writing the code, but we'll see how far we get one step at a time here. And then the other parts of your class will be running the wax on the CNC, so you have to sign up for that time frame. So that's kind of what the other thing we're going to be doing. And it'll take several weeks to get everybody through running the CNCs. So don't expect to be done with that next week. By the time we get 20 people through it, it might be 3 weeks from now. Okay, so we are going into custom subroutines. So I called it custom subroutines because you have to come up with something custom. All right. Okay, you must select the custom subroutine or an emblem or to machine. You're not allowed to use the hearts and diamond example before. Come up with something else. And it can't be a square on a circle. It can't be that lame. You got to do something at least a little bit different. I'll give you some examples here in a minute. Hopefully I don't run out of batteries on my computer here because I forgot my power cord. be sure to open and review the example lab. Well, there's an example lab there too. It has some of the numbers in there. I'll probably put the, I think I put the hearts and diamonds one in there too, so you can just use that one. We are going to be using a 1/2 inch piece of basically a plexiglass, which is acrylic. It's cast acrylic, which cuts real smooth, and it's made out of glass. So it's kind of cool, and you can make it into like a night light if you shine a light into the side of it or something like that. Okay, so our G92, which tells it, if you remember that one, G92 says, okay, where's the machine home at? It's usually in the upper left corner somewhere. That's where machine 0 is. Okay, and it says, well, where am I going to program the part 0 at? What's the distance between them? Well, since we're using a 1/2 inch piece instead of a 1.5 inch piece of wax, we're using a 1/2 inch piece of plexiglass. It's going to be 1 inch difference roughly to the top left of it. So that's why we got 5.062 instead of the other number. I think we put a 1/2 inch thick spacer in there too that gets it high enough above the clamp that you won't hit the clamp if you're machining. So it's only a 1/2 inch difference, okay, or roughly a 1/2 inch difference. So we'll have to change our G92. That's very important. I'll try to be checking for that when I check everybody's program before we run it. But make sure on G92 the Z is different. It's not that 4.5 number. It's 5.062 because it's farther. It has to reach farther down to get to it. If you left it in there, it'd just machine error, I guess. But and you won't see it on your virtual machining because the G92's got a slash in front of it, so it doesn't actually run on the virtual. It only runs on the real machine because there's no machine 0 on a virtual machine. Okay, please see below, for example, notice there is no line numbers on O and P. Oh, is it just on O? I guess it's just on O, yeah. So on the subroutine, which is a little weird, it won't automatically number them. Don't put one in. Sometimes they see students actually put the N, like N99, they'll put the line number in there. The O doesn't get any, okay? It won't automatically put one in either, but you don't want there to be a line number on the O. Okay, and it's not a 0, it's an O. In the subroutine, okay, so we're not going to go so deep. So I think in my example, I went negative 0.2 deep. We're going to start out at 0.1 above the part. Okay, a little bit less than 1/8 of an inch above the part. And then we'll drop it down 0.2, that negative 0.2. So it's going to be in relative now. So remember, we've been doing everything absolute. Well, it's going to be in relative. So it'll actually only, if it's a 0.1 above and it drops down 0.2, then it'll end up being 0.1 in the part. And my example shows that. I want you to use 0.15 and negative 0.15. So it only basically goes, or 0.1 above, and only goes 0.05 into the part. Because we're using a real skinny bit and it breaks off real easy, and we broke a lot of them usually. So I'm trying to avoid breaking more bits, okay? If you want to get a smaller width, then it's an 1/8 of an inch bit. If you want to get a smaller width groove, just don't go as deep because it has a ball on the end of the bit basically. It's called a ball nose bit base, and it's round. So if you're not in as deep, it's not as wide. Okay, it's not flat on the bottom of it like most of the bits we've been using. Okay, let's go into the lab here. This is definitely a little bit more complicated than what we've done before, but don't get too frustrated about it. Everybody always gets through it. You just got to take your time. Okay, so the idea is on one side of the glass, you're going to make one pattern. Okay, now this represents an 1/8 of an inch bit, so this is only 1/8 of an inch wide. The heart is an 1/8 of an inch wide. That's what it's going to cut. If you want it to cut less than that, like a 1/16 in a wide, just go down negative 0.13, and it'll actually go into part 0.03 since we're going to be 0.1 above, okay? And then it'll only be a 1/16 wide. So you can draw any width you want. Don't really care. You can make it a 1/16 wide groove if you want. You can make it an 1/8 inch wide groove. Sometimes some things patterns that you want to use, an 1/8 will run into each other too many times. It does not have to have 5 patterns like this, but it does have to have at least 2. Okay, so if you want to, a lot of times what I see is somebody will do like a St. Louis Cardinals one, and they'll put an S on one side and 2 S's, okay, and then an L on the other side. Now the L has to be a reverse L, because if you look through it, remember it's going to be mirrored. If you think about that, it's a little complicated, but so you got to remember you're going to be flipping these parts over to machine the other face. So you're doing an S right here, and you'll actually put an L over to the right of it. Hopefully you can see my mouse, but I'm above the heart here. So you got to think about how you're going to do the pattern. All right, so you have to have at least 2. This hearts and diamonds one has 5 of each, but you have to do at least 2 of the same emblem. And remember, we're only got a 3x3 block, and it is a 1/2 inch thick. And what you can do is, like I said, once you get the pattern done, you can actually bore a little hole in the edge of it, get a small flashlight and put it in there, and it becomes a nightlight for one of your kids or something like that. It's kind of, we've made a few hundreds of them, so it's always something. You can buy those little flashlights anywhere and just drill a little hole in the edge of it, and they can turn it on and off, so it's kind of cool. I'll try to show you an example in class. But then in this example, diamonds would be on the other side. Okay, so this example is basically a print like you'd get from a customer. Notice the dimensions are not using ordinate dimensions, okay? They're basically just using regular dimensions. So this is how you typically would draw it. All right, so that's the beginning. The first thing you'll want to do is you'll basically get on your template with your 3x3 part and try to find a pattern that you'll like on both sides, because you got to do two of them. So I'll do an example showing you that here in a second and just get you started. Or I'll just go through the examples, and I'll probably just walk around and help people, because it's really not too bad. So I'll probably do the hearts and diamonds pretty fast. But so what you do is you get your template, like right here, okay? And this is our standard template, 3x3, nothing fancy. All right, and then you make a copy of the rectangle just over to the right of it, so we can do it on the same drawing, so we don't have to flip back and forth to 2 drawings. So all this is a copy of your rectangle and your part reference 0, which is this little symbol there, that little hatch symbol with that 0, 0. Copy that in the rectangle straight over to the right with the 0, 0. Now, when you dimension the 0, 0 positions, you will have to move your UCS, which is real easy in AutoCAD. You just type UCS, pick the starting point and pick the ending point. Okay, now I'm going to do that with you here in a second. And then after you get those blocks moved over, the next step would be go on the internet and figure out what kind of pattern you want to do, or just come up with something in your brain, whatever you want to do. But you got to come up with a repeating. And it has to be at least 2. It could be more than that. I've had somebody did the yin yang symbol, which maybe you know what that is, maybe you don't, but they did that twice. So there's a lot of different things. You only got 3x3 blocks, so it can't be too complicated. But there's a lot of different possibilities there with sports teams and everything else. So on one side, you got to do one emblem. On the other side, you got to do a different emblem. And there's got to be it's got to repeat at least twice, okay? And of course, like the heart has to be exact same size on both places. It can't change because it's a subroutine running the same code. Now notice the heart to the right of the template here. Look at the heart on the right. Notice how I dimensioned that. I use linear dimensions from one point where the tool is going to be to the next point the tool is going to be, and then to the next point the tool is going to be as it moves around. So one would be a straight line G1, one would be like a G2 going around the curve, one would be another G2 going around a curve, and then back home. Okay, and notice they're all linear, they're not absolute, because in the subroutine we have to run linear programming. So you'll have to use X, Y, and if it's going to the left or down, it's negative. Going to the left would be a negative X, going down would be a negative Y. Okay, which these few dimensions on that heart are all the dimensions I need to move all those positions. I don't need the ones on the right side because they're the same thing. Okay, now yours might be a lot more complicated. But you need all the X, Y linear dimensions, not ordinate dimensions, because these are ordinates over here. And notice on the left, on the template, on the rectangle, wherever I start machining, I have the X and Y positions, because you'll have to type in the X and Y positions before it goes down and runs the subroutine. Okay, so it's going to go down and run the subroutine. After, with your M98, it'll go down and run it, but right before the M98 code, you'll need the XY position, so it goes there, then goes down and runs the code, then comes back up to the next XY position, then goes down and runs the code, then goes back up to the next XY position. Okay, so we're going to go through the programming next class, but I just want you to understand how it's going to work. So try to get something completely crazy. And I'll do that in front of you in the video next class. Main thing I want you to focus on today is get your drawing done right. Okay, so this is an example. Yours should be very similar. So you should only have a beginning point on your first pocket or whatever you're machining. Okay, and you have to show me what you're going to make. I have to see it. So if you're not in class, you're going to have to upload. You're going to have to upload a picture of it, or you're going to have to send me an email telling me what you're doing, and I'll send you an email back. But I'd like to see a picture of what you're doing so I have an idea whether it's going to work or not. Because a lot of students pick stuff that's just impossible with our machining. So I need to see it. Okay. To basically do this, it's real easy. So I'm going to keep going on this video and show you how to get this started in AutoCAD. Okay, and then you have to do the same thing with your emblem. Okay, and it's a little bit tricky, but it's not too bad. The first thing you do is basically just like we did. It's a lot like the initials. Okay, remember how we drew the center line of our initials? Remember that? And then we offset everything for the width of the bit. So we're doing the same thing here. We're just going to draw the center line of our travel of our bit, and then on the right side we're going to copy the bit location into everywhere it changes. So like where it goes from the starting point and then it starts having to go to a curve on the heart here, I have to drop in an 1/8 of an inch bit. And if you're going to make it a 16th width, drop in make a new bit a 16th of an inch diameter. Sometimes the 1/8 is too much for you. Okay, you can't go more than that. I don't want you to use a 1/4 inch bit. It doesn't look as good in that plexiglass. Plus, there's not enough room usually. I mean, if you have something really custom you want to talk about, we'll definitely talk about it. But open up my template real quick here. I'll go ahead and just start drawing it. So you do have to be a little creative on this one, okay? So the first thing I'm going to do is I'm going to copy all these items to the right. All right, and it doesn't matter where you put them, okay? So I'll just kind of watch me for 5 minutes, and you guys can all get started on your own, and I'll walk around and help everybody. But pay attention to this so you're not so confused when you start. It won't take me long. So I'm going to pick all that stuff. All right, click copy. Maybe I am. Copy selection. Pick a point. It really doesn't. I should turn my ortho on probably and my snaps on. Turn my ortho and snaps on. And just move it to the right. Okay, now remember later when you're actually working on this one, you need to move that UCS, and you can't pick it. It does let you pick it. That doesn't really work because it does. I don't know. There's a bug in AutoCAD that the ordinate dimensioning doesn't work. So when you want to move your UCS over there, just type, in case I forget, just type UCS. Okay, and pick your starting, or just pick where it goes, nothing else, and then hit enter. Okay, and I'm gonna hit undo so it goes back. Right, because you need it when you do your ordinate dimensioning over here. You have to have your UCS over here. Nothing else too complicated about it. So when you're doing your heart here, okay, so what you want to look at is like the example. That's how you draw it, basically off the example. You don't necessarily draw it off. You're not allowed to do hearts and diamonds anyway, but you figure out which one you want, okay? And you figure out what position you would start off on to start machining your subroutines, okay? You gotta think about it. Well, I'm only going to be going to one position on this, and the actual machining is done in the subroutine, okay? So just to draw this heart, I'm going to do a rectangle just so I can do it quickly. So you pick a rectangle, say I'm doing a rectangle here, all right, and my UCS is there. This is 3 by 3, so if I'm going to do a 2 by 2 or a 1 by 1 rectangle, and I need 2 of them, that would be 1/2 inch, 1/4 inch between them. So I'm going to say at 0.25, comma 0.25. Okay. Try again here. Evidently, I didn't do it right. At point, oh, That's not at, it's absolute, sorry. So you just put 0.25, 0.25, comma, 0.25. Okay, and then if I want to go from there at 1, comma 1. This is a really simple example. And now I want to basically put a 1/4 inch from there. So just to give me a nice starting spot, which I maybe should have done in the first place, I'm going to go over offset and 0.25 and bring this line in and give you a nice spot to start with. And now I'm going to draw that rectangle again. Okay, so at -1, comma -1. Okay, so now I've got my 2 rectangles. Now these will basically be where I start. So I'm going to change properties on these and change the line type to center line. And I'm going to change the color. I typically use light green because it shows up better. And for some reason center line is not working. Let's see here. Okay, so I'm going to change my LTS's line type scale. It must be set too high on this because it's not showing up. So LTS's line type scale, type that in. It was set at 1. I'm going to make it 0.5. There it starts showing up. Okay, so you can always make it smaller if it's not showing up. What happens is the line type's too big and it doesn't fit. It can't make the dashes and stuff are too big. So I set LTS to 0.5 and that fixed that. All right, so now I've got my 2 patterns, okay? Now say I'm going to make them 1/8 of an inch wide, which would be standard. So I need to go half of that. So I need to offset at half that distance. So I'm going to basically pick offset, and then I'm going to basically offset at 1/16. Okay, but then I'll change those to a different color after I get them all done. The first thing I get is where it's going to run. And after I get all that done, I'm happy with it, happy with my design. I just do one first and then copy it up over here to make sure it's going to fit. You remember, you only got a 3x3 block, okay? So just focus on one of them and then copy. You can always move it around too. I'm doing both. You probably shouldn't have done that. Mine's pretty awful simple here. You're not allowed to do rectangles and circles. Just to show you how it's doing it. So now I'm going to switch that over to another color. Just kind of pick one. I like cyan, I guess, and change it to a bilayer or continuous. All right, so that's going to show the tooling path. Now what I want to do is I want to copy my tool, and I've got an 1/8 here. If you want to use a 16th, you need to make a 16th circle. So CO is copy, pick it, enter, make sure I go to the center here, and I'm just going to put it in the center point, or the starting point. Now that looks wrong, but remember this thing's going to go all the way up and down. So this line would actually, if you want to see the path, I'm going to explode these 2 rectangles. Okay, and then I'm going to extend them. So that's the actual path that the bit's going to make. Okay, so it's going to look like that when it's done machining. Right, so it's going to go I'll probably go up, and then it's going to go over. Looks like I missed a couple. So that's the path of machining, but in the end it's going to look like a rectangle because it's going to overlap. Okay, so I'll leave this one like this, but you got to remember it's actually traveling all the way around here, okay? So I just kind of wanted, you don't necessarily have to draw that. Just remember, though, it does go up and it does cut right there. All right, when you get that done, you just basically go to your, like we did last time, we go to Ordinate Dimensioning. We should have our 0, 0 in the right spot, okay? And you just dimension. The only place you dimension on here is the beginning XY. Okay, now I should have been in dimensioning layer. All right, I'm going to have to change to red. I think we created a dimensioning layer. Hopefully you did. I made mine yellow. Yours is probably red. I did yellow so you can see it better on the overhead projector. Okay. Now we go to Ordinate Dimensioning. And we only dimension, well, looks like my UCS is back where it was. How is that possible? Delete. Okay. On my UCS. And I'm going to put it right here. And I'm going to try again. Ordinate. Even though all right, something's wrong with my UCS on here. I'll have to figure that out because it's still thinking it's 8 inches over there somewhere. And it's definitely not. So that's the problem. That should be 0.25. So I'll have to figure that out in a minute. But those are the only places you dimension. Hopefully you don't run that same problem. It's back where I moved it a while ago. So those are the only 2 positions you dimension on this one. And then you make a copy of the rectangle you just did. CP, copy. And put one right over there, okay? So it doesn't matter where you put it. doesn't make any difference. Now what you want to do is copy all the places your bit's going to change. So every place it changes directions or goes to a curve or something like that, you need to drop it. Oops, I messed it up. Okay, so I've got my bit in all 4 spots. And now I need to make the XY coordinates, okay? So you do that with linear, all right? And you basically do, so the first one I say I'm going to go right to left. I said I'll go up. Well, I guess I'll start out with that. So I know what this one is. It's too easy. It's 1. But you basically put your 1-inch dimension on there and say this one's not 1. Say it was different. Well, I dimension that one up there and say this one's different, which I know it's not. But if it's the same, you don't need to dimension it. But I'm just showing you put all your dimensions on there. And these are all in linear, okay? Because I'm gonna tell this I'm gonna put that G91 in my O-line code. G91 just tells the machine go relative or incremental distances, okay? So I'll just put G1, X0, Y1, and it'll go straight up here. And then I'll put a next line in my code, I'll put a G1, X1, Y0, and I'll put a next line B. I won't have to put G because it repeats. I'll just put X0, Y -1, and then X -1, Y0 in my next code. Okay, so it's all incremental distances in your subroutine. Okay, and then it'll pop out of that subroutine and it'll go back up to the top, and that'll end up, and that line will be the next location, 1.75, and whatever that X is, X number, Y number, and then it runs down and runs it all over again. That'll be a M98. And I'll run down and run that again. Okay, and then on this side, you do the exact same thing, except this is your second pattern. It'll be on the back side. Remember, it's mirrored because it's going to have to flip it over. So whatever you draw over here needs to be a mirror image. Or whatever you draw here, remember when you put it underneath this one, it'd be a mirror image. Okay, so if you want two, I'm saying that because if you want 2 images on top of each other, like say I had one in my circle under the rectangle, I would draw the circle. I would mirror this in the middle, and I would draw this, or I'd draw it first, maybe right underneath it, and then mirror it. Because the circle would have to actually be drawn right here and right here, because it's on the back side. If I'm flipping it right side up and then machining it, and then flipping it upside down and machining these over it. So like if I want the circles to show up directly underneath my rectangle, they need to be a mirror image on the block. So they would actually be right here to show up underneath. They'd be to the right or the left. Okay. So hopefully you understand that, but it basically has to be a mirror image to show up underneath it. Now, if you want them to show up not underneath it, then draw them right underneath it, because when you flip it, they won't be. Okay, because they'll be on the mirror image side. Just remember that the second one is it's going to, when you look through the block, it'll basically be on the opposite side because you're flipping your block to machine, because you only machine the top face of it. Hopefully that's as clear as I can get it. If you're having trouble, make sure you come to class. There's definitely room in here for you. So come on into class and we'll get through it. So we're going to be working on this today and next Thursday, and that will be it. And then we'll be basically getting into the lathe. So, and then you'll have to, don't forget, you have to sign up for the time frames, which I'll post that here in a little bit. All right, does anybody in class have any questions before we get started? I'm sure some people online have questions too. So if you have any, bring them up and I'll try to get through it. I know that's a lot of information real fast. Because the main thing to do is just jump out on the web. So some examples of things I've seen, like sports emblems. Somebody did a barn. So think about stuff that you can look through and it looks cool, you know, or just do two different things on opposite sides. So I'd go out on the web, you know, and just if you're in sports, just type sports emblems. Okay. And there's a bunch of them right there. The Colts would be easy. You could do a Colts and whatever heck else they have in there. The Kansas City would be a great one, you know, something like that. It doesn't have to be that. I had somebody do a deer head. Somebody did a crossbow through a heart and gave it to their daughter. Somebody, what else have I seen? I don't know. A lot of things like that. I mean, you can do something even like that eagle head there for the eagles. I mean, you could do something like that too. So you can actually, look at the eagle head in this example I have up here. See how it goes to a point by the feathers there? you can actually have the bit come out of, so like when you go from your curve here, the curve on that feather would be like a G2 or G3. So you start out on the thick part, and then the next G position for the G3, your Z would come out of the part a little bit, and we use that ball nose bit so it'll actually go to a point. So you can machine a point in this if you really want to. It's not easy, but you can do it. Don't take it on unless you're feeling brave. But I've definitely seen a lot of them do it, so it does come out pretty nice. So, but you gotta have the Z come out of the part, because remember it's a ball nose bit, so that the tip of the circle will be real skinny. So it won't be perfect. It'll get tricky, but it'll definitely look better than trying to cut it wide the whole way. So I need to see a picture of what you're planning to doing if you're not in class. So you'll have to email me a picture to this lab, put it in that lab, and just send it to me, and then tell me you did it, so I know to look for it before you start programming it. If you're in class, of course, you gotta show me before you start. Anybody have any questions? Like I said, it could be anything. You could do you could trace a barn and put a barn with a fancy barn door on it. I mean, there's a lot of different, the yin yang symbol. There's a lot of, it doesn't have to be a sports symbol. It could be anything. Any questions? Okay, I'm going to stop the video then.